Okay, we're going to take a look at this Trig Identities test review. This one's going to be pretty fast, I think. So this is tangent of 285. A couple ways you can do this, but we know that 285 is not in our unit circle, so I'm going to basically say that I'm going to take two angles that either can be added or subtracted to make 285. So I'm going to go with 225 and 60. Okay. So I know from the formula chart that I'm going to give you that the tangent of a plus b is going to equal the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. So let's change my pen color and say, okay, that's going to equal the tangent of 225 plus the tangent of 60 over 1 minus the tangent of 225 times the tangent of 60. All right. Now I have to figure out, well, what's the tangent of 225 and what's the tangent of 60, pretty much. So 225 is an angle that's about right here, right in the middle, in the third quadrant. That's 225. So get another color. Let's use green. So this reference angle, in other words, is a 45-degree angle. So I now know that these two sides have to be negative root 2 over 2 and negative root 2 over 2. Okay, and 60 degrees is right here, and those sides will be root 3 over 2 and a half, respectively, from the unit circle. So I'm going to look at this and say, okay, the tangent then is y over x. So for 225, the tangent of 225, that's going to be negative root 2 over 2 over negative root 2 over 2. This y over this x actually right here. So that's going to be 1. Negative divided by negative is a positive. Here, we're going to have this y value divided by this x value. So it's this divided by this, which actually just turns out to be root 3. So this is 1 plus root 3. So right here, this is 1. And right here, this is root 3 is what I'm telling you. And there's a plus sign in between them, so that's what I have. And then I have 1. We know this is root 3 and this is 1. Sorry, this is root 3 right here. And this is 1. So this becomes 1 minus root 3. So to resolve this, I'm going to multiply by the complex conjugate, I guess is what it's called, of your bottom part, which is right here, 1 minus root 3. So I'm going to say multiply by 1 plus root 3. Get a difference of squares here. And what that's going to do is allow me to get rid of the radical on the bottom. So I say, okay, 1 times 1. Let's actually just FOIL this out like we're multiplying, right? So we'll say on here we have 1. 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is negative root 3. And then negative root 3 times root 3 is minus 3. On the top, we'll have 1 times 1, which is 1. 1 times root 3, which is positive root 3. Root 3 times 1, which is also root 3. And then root 3 times itself, which is 3. So what I see here is I have 3 plus 1. That gives me 4. And I've used these up. I have root 3 and then root 3 again, so that's 2 of them. So plus 2 root 3. This will be over. These root 3's cancel. Root 3 and negative root 3 in the middle. These two middle terms cancel because we have this difference of squares. So we got 1 minus root 3, which is negative 2. So what this really is now is two fractions. It's 4 over negative 2. And then we have plus 2 root 3 over negative 2. So 4 divided by negative 2 is negative 2. And this divided by this, the 2's cancel. So I got root 3 divided by negative 1. So negative root 3. This is your solution for number 1. That was the whole thing. Okie doke. So let's go on to the next question. and press on from there. Make sure everything's working. Everything seems to be cool. All right, so let's do cosine of 195. Alrighty, let me get another pen here. Let's use red, I guess. So cosine of 195 is actually a couple ways you could do that, but I'm going to say that's the cosine of 135 plus 60 is what I'm going to say. So I use my formula chart again, and I see that the cosine of a plus b will equal, let's actually write that, okay? I'm going to write that over here. The cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a times the sine of b. That's the formula we're going to use. For cosine, remember, if it says plus, we're going to use the minus. So what I really have here is cosine of 135 times the cosine of 60 minus the sine of 135 times the sine of 60. So let's just take a look at where those angles would be. 135 is right in the middle here. That's 135. And 60, of course, is right about here. So let's change the color up again. And we'll say this reference angle here is a 45-degree angle. So if that's a 45-degree angle, then this is going to be root 2 over 2 and negative root 2 over 2. And if this is a 60-degree angle, this is going to be a half, and this is going to be root 3 over 2. So I pretty much know what this is going to be now. So I figure out what is cosine of 135? It's this right here. It's negative root 2 over 2. The cosine of 60 is right here. It's a half. Minus the sine of 135, which is this right here, positive root 2 over 2. Times the sine of 60, which is root 3 over 2. So we just multiply straight across. Negative root 2 times 1 is negative root 2. Now we have a minus sign. Root 2 times root 3 is root 6. I now have a 2 times 2 and then a 2 times 2. So here I'll have a denominator of 4, and here I'll have the denominator of 4. So technically I could write it as this, both over 4, but I'm going to combine it as one fraction and say it's negative root 2 minus root 6 all over the common denominator that you see here, which is 4. So that's my solution for that one. It's pretty straightforward. Let's go on to the next question. This is the kind of the tricky part here where you're doing the Pythagorean Theorem and, you know, law of sines and cosines, what have you. So here I want you to box all your answers so I can see what you're doing, but calculate the length of AC. So I have this point here, A, and right here actually is what I want to see. So I'm going to go from A to C right here. And I have to find that length, but this is a cuboid, so I can assume, because it's a cube, that this angle right here is a right angle. So this is basically a right triangle that's laid face down here. So I can use the Pythagorean theorem to figure out this unknown length AC. So I'm going to say AC squared is equal to 7.2 squared plus 9.6 all squared. All right, so let's go ahead and use a calculator. All righty, so I'm going to say, what is 7.2 squared plus 9.6? Is that what it was? Squared, right? And that's 144. So I'll take the square root of that, but you really should know that's 12. So let's say let's prove it. Square root of 144. And that is in fact 12. So that answer is going to be 12. So AC, that answer is going to be 12 meters. So that's done. Calculate the length of AG. Let's change the pen color so you can see things better. So I'm going to go from A to G, just like we did in class. Right over here. Calculate the length of that. What I now know though is that this length here on the bottom, along the bottom of that, the floor, is 12. Okay, we just found that. So I know this height here also, this height here is the same as this one, is 3.5. So to find this diagonal that I want right here, all I have to do is use the Pythagorean Theorem again, because this is another right triangle. So I have this squared plus this squared, this is 3.5. This squared plus this squared is this unknown AG squared. So AG all squared will be equal to 12 squared plus 3.5 squared, because it's another right triangle. So let's check that on a calculator. Alrighty, so we got 12 squared plus 3.5 all squared. Take the square root of that. So you can do control minus sign. There you go. So that answer will be 12.5 when we do that. So AG is 12.5 meters. So this is 12.5 right here, this whole thing. And then last but not least, find the angle that AG makes with the floor. All right. So here's the floor right here, and here's AG, this distance we just found. The angle between the floor and AG is this theta angle right here that I'm looking at. So I need to find that angle is what it's asking me for, this diagonal and the floor. So there's a couple things I see here. I have all the sides, and this is a right triangle. So this is actually a really easy problem. Okay, there's a lot of different ways you can do this. Because I have this height here and this bottom here, I didn't really even need this answer. I could say that the tangent of theta, this angle, is the opposite over the adjacent side. So the opposite side of the angle is 3.5, and the adjacent side is this 12 that we found from the first question. So to find the angle, actual angle theta, I'm going to say theta is equal to the tangent inverse of this ratio, 3.5 over 12. So theta is going to be, from the calculator, first thing I'm going to do here is, before you do anything, go to dock, go to your settings, and go to your settings again, your general settings, and make sure that you're in degree mode. If it's in radian mode, you're going to have a rad time, as I say. So we're going to make this the default, and now I can go ahead and try to do this. So I'm going to say trig the tangent inverse. I'm going to hit control divide. Right, and I'm going to say this is 3.5 over 12. That's what I said. That's the opposite over the adjacent side. And then this angle should be about 16 something. So if I hit enter, it tells me, of course, this is 16.3 degrees for that answer. So 16.3 degrees is that answer for question C. And that's that answer here, 16.3 degrees. So we're done with this entire question. We've done everything here. Okay, so make sure you box everything. So we got 1, 2, 3 answers. All right, so let's go on next question. Alrighty, down here to this triangle. Very well. All right, so let's get this going here. It says calculate the size of the angle ABC. So here's A, B, and C. So what they are asking me for is this entire angle right here. All right, that's really a piece of cake given what they were showing me here. This is a right triangle, I can see. So if I turn this right triangle sideways, like this, I know this is 100, but I need to figure out this leftover bit right here. I need to figure out what this angle is. So to do that, I'm going to turn this right triangle that I have right here on its side, and then I'm going to be looking at this bit. That's the same angle that I have here. All right, we know this opposite side is 4 and this side is 9. Here's the right angle. And I want to know what this angle theta is, okay? This little theta angle right here. It's the same triangle that we see right here and here. I have two sides. I have the opposite and the hypotenuse. So I know that the sine of that angle is the opposite of the hypotenuse, which is now 4 over 9. So that means if I want this angle itself, the angle theta will equal the sine inverse of that ratio, 4 over 9. So that's going to give me some answer in the calculator that I can use. So I'll just go over here, trig, do sine inverse, let's do control divide, and then I'll say 4 divided by 9, and then enter. So that's going to be 26.4-ish about. So I'm going to say that's about 26.4 degrees, and that's going to be that angle right there. So if I add 26.4 to the 100 that I already have, this entire angle is 126.4 degrees, which is what I wanted. So that's your answer for this question, first one. All right, now it wants me to calculate the length of AC, so let me change the pen, and we're going to have to get a little more creative here for this particular answer. So I have A, and I'm going all the way over to C, and I want to know that side. So what I have here is a side, an angle, and a side. It's a sassy triangle, side angle, side triangle. So what we're going to end up using is the law of cosines. All right. And there's three different ways you could write the law of cosines. But based on what I have here, if I call this angle B, since it's already labeled that way, and I'll have little b opposites that. So the side opposite angle B will be little b. If I have angle C right here, this will be the opposite side, which is little c. And if I have angle A here, this will be the opposite side, which is little a. So if I want to figure out B, that's the same thing as AC here. I'm going to say that B squared is equal to A squared plus C squared minus 2AC times the cosine of B. That's one of three versions of the law of cosines. So I'll just use this formula. I'm going to figure out B squared. I know A squared is 10, so this is going to be 10 squared. C, I told you, is 9 right here, so plus 9 squared minus 2 times 10 times 9. And then the cosine of angle B. And angle B, I'm telling you, is this whole thing I decided, which is 126.4. So keep in mind, if you got this previous question wrong, you're going to get this question wrong because this angle will be bad. But I don't believe it is for our case here. So let's use a calculator. Actually, let me set this up a little bit. Let me set this up a little further before we use a calculator. So I'm going to say B squared. I know that 10 squared is 100 and 9 squared is 81, so that's 181 when you add them. And then I got 9 and 10, which is 90, and 2 so that's 180 when I multiply it. So it's times this. It's going to kind of make it easier to type it into a calculator pretty much. So I'm going to say, all right, use a calculator. I'm going to have 181. Oops, see, 181 minus 180 times the cosine of 126.4, thereabouts. So that'll give me that, and that's the square. That's B squared, which is not what I want. I want B, so I had to take the square root of that answer. So I'll take the square root, which is control minus for that answer, and it tells me that length is actually about 16.96. Okay, so you can say for that answer 16.97, I guess, is okay. So this is going to equal 16.97, or if you went ahead and said 17, that's okay. So 16.97 or 17, either one of those I'll accept, close enough in that ballpark. So that's the answer for number 4. That's all of them right there. And then last but not least, save the best for last, these are the trig identities, and these are pretty straightforward on this review. They're really intimidating for a lot of people. I'm not really sure why, but I'm just trying to get one side equal to the other side, and I only manipulate one side, and I use every identity at my disposal that I know. So I'm going to make the right side equal tangent squared. That's kind of what I'm going to do. So right here I have a cosecant squared, so I'm going to go ahead and rewrite that as 1 over sine squared, since cosecant is a reciprocal of sine and vice versa. So tangent squared, if I turn this into sines and cosines, it's going to be sine squared x over cosine squared x, and then minus 1. So what I'm going to do is change the pen color so you can see I'm going to cross these out. So what I have now is 1 over cosine squared x minus 1. 1 over cosine is the same thing as secant, so this is really the same thing as secant squared x minus 1. But I know there's a trig identity that says tangent squared x plus 1. Oops, let's not do that. Let's undo that. I always write too fast and make little mistakes here. So let's write that again. Plus 1 equals secant squared x. That is a Pythagorean identity that we have in our formula chart. So if I subtract 1 from both sides, it's going to tell me that the tangent squared x is actually equal to secant squared x minus 1. But this happens to be what I have here, and this is equal to tangent squared x. It's a trig identity itself, so this is actually equal to the answer that I wanted. So this is the actual solution right here. We're really done with this. That's all there is to it. So number 6, let's hash it out, and then we'll be done with this video. I'm going to turn this left side into the right side. I'm going to make it look the same, only manipulating the left side. Okay, so I see right here, I have this, tangent squared x plus 1. If you recall, I just looked at this. It's right here, tangent squared x plus 1. What is that equal to? I told you in this trig identity sense. This is equal to secant squared x. So that's the same thing. All right, it's secant squared x. All right. And since I know that, secant squared x is actually the same thing as 1 over cosine squared x, because secant is the same thing as 1 over cosine. So I have this. I'm going to use everything else. So I'm done with this. I'm going to drop this down. Tangent is the same thing as sine over cosine, very common knowledge. Drop down secant, which is the same thing as 1 over cosine, another commonly known thing. So this is what I have. I have this, and I'm basically adding this, is what it says right here, right? Adding it. So let's add that. Let's take a look at this. Let's multiply straight across. So I say sine x times 1. Sine x times 1 is sine x. And I got cosine times cosine, which is cosine squared on the bottom. In front of it, I have 1 over cosine squared, and that's actually, now it tells me I have a common denominator, cosine squared, cosine squared. So I can write this as a single fraction, 1 plus sine of x all over cosine squared. This is cool because it's the same thing as your answer. So that's all there is to it, really. So that's a quick review. I hope you watch this, and I hope you realize that, you know, if you practice, the trig identities are not very difficult to get through. But I thank you for watching, and I'm going to post this, and I'm going to post another one for review for tomorrow. So good luck on your test, and I will see you in class. All right, bye.